A fluorescent tube light can be seen in all walks of life, whether they are factories or offices, houses or hospitals. Tube light is used everywhere. But very few people know how fluorescent tube lights really work. In today's video, we will try to understand that. In order to understand tube light functionality, we will first have to understand the structure of tube light. A tube light is essentially a glass tube filled with mercury and various other inert gases such as argon. In addition, the inner side of tube is coated with phosphorus, and on the sides of the tube, the electrode filaments are installed. Whenever a high voltage is applied on the electrode filaments, they will heat up and emit electrons. This process is called thermoionic emission. The presence of high voltage on electrodes pushes the electrons from one electrode to another, which creates an arc that converts mercury present in the tubes to vapors. This whole process creates ultraviolet light, which gets converted to visible light after coming in contact with phosphorus coating on the inner side of the tube. Now a question arises: how a high voltage is created in the tube light electrodes? The required voltage to create an arc in the tube light can be up to thousands of volts, which is not available in household electric outlets. To solve this problem, some electronic components are used efficiently with the tube light. These components are called starter and ballast. Among these, let's first try to understand the functionality of a starter. If we open a starter, then we will see a capacitor and a neon bulb inside it. Inside a neon bulb, there are two metallic strips, one of which is made of two different metals. It has a property that it bends whenever temperature rises. The temperature is risen in a neon bulb when an AC voltage is applied at neon bulb terminals. The applied AC voltage creates an arc inside neon bulb of a starter and consequently increases the temperature. As a result, the bimetallic strip bends and creates contact with the other metal strip. As soon as this contact is made, arcing process in the neon bulb stops and it starts to cool down. When the temperature drops below a certain value, then the bimetallic strip returns to its initial condition and the contact is broken with the other strip. This creates the same cycle of arc creation inside neon bulb. As a result, this whole process continuously starts to repeat itself, and the neon bulb starts acting as a continuously turning on-off switching device. In order to understand how a starter is useful in a tube light working, we will have to understand the third circuit element of a fluorescent tube light called ballast. Ballast is essentially an inductor coil, and as we know that an inductor opposes any change of its current due to its magnetic field. The changing electric current in an inductor induces a high voltage on inductor terminals, which according to Faraday's law is proportional to the inductance value and the rate of change of current. This means that if we can suddenly interrupt inductor current to zero, we can generate a very high voltage at the terminals of the inductor. This high voltage can then be used to start initial arcing in the fluorescent tube light. After understanding inductor ballast functionality, it will be easier for us to understand the fluorescent tube light functionality. For this purpose, we will use the tube light connection diagram, and we will represent all electronic components of fluorescent tube light with their electrical symbols. And we will see that when at time 0, tube light turns on, then what happens inside the tube light circuit. At 0 time, grid voltage is applied at the terminals of the tube light. At this time instant, there is no current flowing inside the circuit. Therefore, all voltage is applied at the terminals of the starter and the tube light. The voltage provided by a home electric supply is low to create an arc inside the tube light, but it is sufficient to create an arc in the starter neon bulb. This is because the distance between the starter neon bulb terminals is much smaller than the tube light terminals. As soon as the arc is created in the starter temperature starts to rise and the bimetallic strip inside it starts bending. At one point, the bimetallic strip bends enough to create a contact with the fixed metal strip. This creates a current flow path through starter and a heavy current starts flowing through ballast and starter. Another consequence of contact creation in the bimetallic strip is that the process of arcing stops in the bimetallic strip, and the bimetallic strip starts to cool down. As a result, the bimetallic strip will return to its original position and break the electric contact. At this point, the current inside ballast and starter will collapse to zero in a very short span of time. And as we know that this will create a very high voltage across ballast terminals due to the collapsing magnetic field. This surge voltage is also applied across the tubelight terminals and is so high that it creates an arc inside the tubelight and ionizes gases present inside the tubelight. Consequently, the ionized gas produces ultraviolet light, which is then converted to visible light after coming in contact with phosphorus coating along the inner side of the tubelight. After the ionization of gases inside the tubelight, it acts as a short circuit. As a result, the roll of starter in parallel with tubelight finishes. This is the reason that even if we remove a starter after the tubelight starts working, the tubelight will still continue to work. So far, we have not discussed the functionality of a capacitor present inside the starter. This capacitor reduces the electromagnetic interference created by the switching action of starter and ballast together. When the starter opens the current path in the tubelight circuit, then the collapsing magnetic field of ballast at the time creates an electromagnetic interference. The capacitor role is to reduce the abrupt change of current and provides an alternate path for ballast current to flow. We hope that till this point you have understood the functionality of a tubelight. For your curiosity, we ask a question. In many occasions, after we turn on the tubelight switch, the tubelight takes some time to turn on. And in this time instant, starter circuit turns on and off multiple times. Why is this that the tubelight does not turn on by one turning off instant of the starter? We will put the answer of this question in the video description, but we recommend to first think the answer yourself before reading it in the description. And finally, if this video has increased your level of knowledge, then please help us to promote this video to others by liking, sharing, and subscribing to the channel. Thank you for your time.